Alrighty, just a quick note. The source code of the code generator is going to be available in the MMO assets folder. I decided to do that basically because there's a lot of potential for making a mistake in this particular video. There are quite a few areas where just a small syntax error somewhere can cause weird results. So I wanted to go ahead and make this particular file available to everyone. I still highly encourage going through the video because code generation like this, getting practice and doing this is incredibly important. At the very least, I'm not going to tell you what the file is called or where it goes, so you'll have to watch the video up until that point at least. Anyway, I don't want to do this very often, but in this particular case, I just see a potential for a massive amount of frustration. So yeah, I guess enjoy the video and check out the source code on the site if you want to. In this video, what we're going to be doing is writing the actual code that generates all of our classes. So just to basically recap what the point of all of this has been, we want to replace Castle Dynamic Proxy. So we know that we're using Castle Dynamic Proxy in both our server and our client. If we open up our client and open up our systems namespace, inside of our client systems class, we come down here to the create proxy for method, and then this leverages Castle Dynamic Proxy in order to create a dynamic proxy. Or in other words, it creates a class at runtime that implements a particular interface, but it allows us to change the behavior of all of those methods that the interface has to implement or that class has to implement. And it does it in the form of this proxy interceptor class. So this proxy interceptor class is responsible for intercepting all the method invocations and performing whatever additional logic that needs to be done. Basically, that's all we're doing. So all the generated code is going to do is it's going to write these classes out that it will accept some sort of proxy interceptor interface and will invoke that proxy interceptor interface for all of the invocations of the different methods. So what I want to do is I've already given a lot of thought of how exactly I want these classes to look when they're generated. I'm going to show you guys an example of a couple classes that will show you guys what exactly we're generating. I'm going to do that inside of the base generated component interface class, this generated file we already have here. Now, you guys don't have to write this stuff out. This is just me showing you guys what the generated code will look like. And this will give us a very good idea while we're writing the code that generates the code about, well, what to have happen. Okay, so basically what we need is so we're going to start off with these components, systems, like for example, a login system. We're going to start off with these interfaces because these interfaces are what the generated classes are going to be based off of. So over here, back in component interfaces.cs, the generated file, just, you guys don't have to follow along with this. I'm just going to really quickly type out what it is I want to have happen. First of all, I want to have something like buzz mmo.base.generated as the namespace. And then I'm going to have a class for each one of these interfaces. And I'm going to name it something like __ ilogin system server. And it'll, of course, implement ilogin system server. So I'll go ahead and include all the stuff, and I'll go ahead and implement the two methods. Now, the actual class itself is going to have a constructor, and the constructor is going to accept a mapped component, which represents the current component that this is, as well as some sort of proxy interceptor. So we can write this as something like isystem proxy interceptor, or we could call this iStatic proxy interceptor, something like that. And we can call this like interceptor. And so what we have here is now the generated class is going to have information about what component it represents, as well as a reference to the interface that's going to be passed in when we generate the proxy. I'm also going to be having a private read-only mapped method array called methods. The reason we need this is I want the interceptor, when we invoke methods on the iStatic proxy interceptor, I want it to be aware of what mapped method was used. However, we can't statically figure out what methods we can't statically figure out which of the methods map to words. It's funny when you're thinking about code that generates code, because you think about the code that generates the code, but you also have to think about when the generated code is compiled and it's running in its particular environment. That's where things get kind of tricky. Basically, what I'm trying to say here is this methods array is going to cache the mapped methods that represent both of these other methods, but it has to find this out at runtime. It can't do this statically. So what we're going to do, it can only find out what mapped methods there are after it's got a reference to the component. Otherwise, it's not going to have a reference to the mapped methods that are running. However, when we... okay, so basically, it's just going to serve as a cache. So, in the constructor, what we're going to do here is we're going to instantiate mapped methods, and we're going to turn it into an array. In this case, it's going to have 2 elements. And that's basically... that, and then basically what we're going to do after this is just say something like methods at 0 equals something like I type of login system server dot get method basic test, or sorry, component dot get method type of get method, and then methods 1 will be component get method type of login system server dot get method do something. So something like this. So now we cache the mapped methods in our array for the particular thing that the mapped component comes from. And the get method should throw an exception will throw an exception if those keys don't exist, which is fine. If we are getting them, if our generated code isn't in sync with a new component interface, then that's obviously an error. Okay, so as far as the methods themselves, so basic test, what should this look like when we invoke it? Well, basically, it's just going to be simply interceptor dot something like intercept void method, passing in methods at 0, because this is going to be the 0th method. This is going to correspond to what we instantiated the method as, and then a new object array of count. We'll make sure we put an object in there to force boxing properly. Otherwise, we'll probably get a compiler error. Or you would get a compiler error. Okay, so that's what like the basic test would look like, for example. And then the do something with an IRPC method will look something like return interceptor dot intercept result method, and passing in methods at 1 and new object should fail. So something like this. Now in the future, we can definitely add more generated code in here. What do I mean by that? Well, basically, we could have these methods perform the serialization and the actual sending of the data to Photon right at this level, removing all levels of indirection and potentially speeding up our network code by a little bit. Now, I'm not going to do that here. I'm going to keep things a little bit indirect for the interests of time and abstractness, keeping our library right now kind of abstract and easy to work with. But once things settle in, this is a place where we could throw in some really nice optimization techniques without changing anything else. Okay, so that's basically what an iLogin system server would look like. We have our mapped component that's passed in, we have our interceptor, and we have our cached methods. All methods will simply defer to our interceptor. Pretty straightforward stuff. So you can imagine this happening for every single system component interface. Now, how do these get instantiated? So that's another interesting question here. Now that we have these classes, how do we instantiate them? Well, the best way to do that, I think, is to go ahead and write some sort of factory method that has a dictionary of all the generated classes in... the reason I want to do this, we could use reflection to do this, but I don't want to have the overhead of reflections invoking constructors, which is kind of a nasty overhead. So since we're generated code already, let's just go ahead and take advantage of the fact that we already generated code. We can throw in whatever we need here. So what I'm going to do here is I'm going to say something like, at the end of all these, I'm going to add one more class, and it's going to be a public static class. It'll be something like component proxy factory. And it's going to be pretty straightforward. It'll simply have a private read-only dictionary of type, and then func mapped component iStatic proxy interceptor, and we'll call these factories, and of course we'll instantiate it, or well, it doesn't really matter if we I don't like field initializers. Also, we have to make sure it's a private static read only, and we'll have a static constructor. The static constructor will simply add a factory instance for every single generated class. So we'll say factories equals new blah blah blah, and then we'll say something like factories.add type of ilogin system server, and then we'll pass in a lambda that has like something like component interceptor goes into a new instantiation of underscore ilogin system component interceptor. So basically that. And then at the end, we'll simply have a public static object create proxy that takes in the two constructor parameters, one, of course, being a mapped component, and the other one being an static proxy interceptor. And the create proxy method will simply return factories at component dot type, and then invoking it with component and interceptor. So that would be our component proxy factory, and it'll have an entry right here for every single different type it can instantiate. So pretty straightforward stuff. The dictionary access is going to be pretty much as fast as or much faster than using the activator .create instance method or using any other form of reflection to instantiate these objects. So that's why I'm doing that here, since these objects will be instantiated fairly frequently every time a user as a system added or removed. Anyway, yeah, sorry that took so long, but it will be very, very, very handy to have this as a reference as we're writing the code that generates the other code. So this is how you would typically go about generating code. You would have a reference like this, and then you would go out and generate this stuff. So let's go ahead and close out this file and exit full screen. What I'm going to do is, I guess we're just going to start, and we're going to start generating code. The first thing I want to do here is I want to go ahead and write the iStatic proxy interceptor interface. So the iStatic proxy interceptor interface will simply have three methods on it. One for intercepting a void method, another one for intercepting a method with a result, and another for having a non-generic IRPC method that intercepts a method with a response. So where I'm going to put that is I am going to go ahead and put that interface in the infrastructure namespace in our buzzmmo.base project. So I'm going to go ahead and create a new interface, and it's going to be iStatic proxy interceptor. And it's going to have a void intercept void method that takes in a mapped method and an object arguments. We're going to have an IRPC method intercept method with response, mapped method object arguments. And we'll finally have an IRPC method of T, intercept method with result. Make sure to get that generic parameter in there. Mapped method. For some reason, I can't type very fast today. Sorry about that. Okay, so that is our interface. We have our intercept void method, intercept method with response, and intercept method with result. 3 methods. And yeah, that's really going to be our static proxy interceptor. Not very interesting. So now that we have that implemented, what I'm going to do here is I'm going to go ahead and open up my build folder. I'm going to open up my BuzzMMO tools project and open up the generate commands, because this is where the command, the actual code generating, is going to happen. Let's launch full screen. And let's go ahead and move this guy over here to the right and zoom out a little bit so we can keep this guy open, our target code, while we write the code that actually performs the generation. Okay, what I'm going to do here is, so basically the first thing we have to really do here is we have to go about generating a component map. We have to go about scanning the assembly, the base assembly, for all of the components that are tagged with the component interface attribute. And I'm just going to take advantage of the code map. Even though it's very important to understand that the component map that we're instantiating and using here to scan for our component interface attributes is not the component map that we're using at runtime. They're two completely separate component maps, so keep that in mind. Okay, so let's go ahead and... So we have our using writer, and I'm going to clear out everything other than that. And then let's go ahead, and what I'm going to do is I'm going to use something called a indented text writer. So I'm going to say using var text writer equals new indented text writer. And then I'm going to pass in writer. And then I'm going to go ahead and say generate component interfaces text writer. And then I'm going to generate that method. And we'll have a separate private method that actually performs the generation, just to reduce the level of indentation. So what's going on here? So we have our writer. We open up a stream writer. This is a file stream that we're writing, that we're setting up, that will access that file. Then we open up an indented text writer. Now, an indented text writer is a text writer, which a text writer isn't a stream. It's a class that wraps a stream that gives you convenience methods for writing text, which is why it's called a text writer. Now, the indented text writer allows us to specify the indentation level of where all the write line statements should go. So that's going to be a huge convenience for us. Now, the indented text writer comes from the codedom.compiler namespace, which brings up an interesting point. I was going to talk about this later, but I might as well just talk about it now, and that is the different ways that we can go about generating code. One of the ways that we can go about generating code that goes into C#, not IL. There's more ways to generate IL dynamically than there is to generate C# dynamically. And one of the ways to generate C# dynamically is to use the code DOM. Now, the code DOM allows you to assemble an abstract syntax tree that represents just arbitrary code. Then you use something like what's called a code formatter for a particular language. And you wire that up to your code DOM, and then it'll take that code DOM and it'll print it back out to C# or VB or F# or whatever code formatter you have. So you can think of the code DOM as an abstract representation of code, and then you can think of a code formatter as something that takes that abstract representation, turns it into physical code. That all being said, the code DOM is an absolute pain to work with. Now, if you absolutely need to be able to do cross-language compilations or you're generating IL and just IL, then yeah, you can look at using the code DOM. But I'm not going to use it because it's so unwieldy for what we want to do. We're basically just writing out text. Now, I do want the text to be pretty, so it aids in debugging. So I will do indentation properly. But I'm just going to write this text straight out into a stream writer. I'm not going to do anything fancy with the code DOM. And that all is going to happen in the generate component interfaces. Actually, before I do that, I am going to go ahead and at the top of generate commands, I'm going to say private read-only component map. And then I'm going to generate a constructor that instantiates the component map. And then I'm going to say auto map assembly. And I'm just going to type of, I'm going to pick a random type out of the buzzmmo.base project. I guess a topical thing to do would be the iComponent or iStatic proxy interceptor. Wow, I wrote that interface like 2 minutes ago and I already forgot what it was called. .assembly. And then the attribute selector is, of course, going to be type of component interface attribute. So what's going on here? Basically, we have a component map that we're instantiating and scanning only once for this particular command's object. So that's because our components that are available aren't really going to change through the runtime of the program. So we can just do this once and cache it. And we are only auto-mapping the buzzmmo.base assembly. We are not auto-mapping the entire app domain. The reason for that is I really want... I'm going to be slightly performance conscious about this code generation. Now, typically code generation is something which it's not performance critical, but in this particular case, this code generation is going to directly impact the compile times of our project. Now, it's going to not be noticeable probably forever. However, I do throw in this little tip that I'm not going to scan the entire app domain for every single class, just because it's so much easier to do it slightly faster by targeting a particular assembly. So it's only going to scan the classes in that one assembly. Okay, so now that we have our component map, I can jump down here to generate component interfaces. Now the first thing I want to do is I want to throw in some using statements. You'll see up here that the using statements that I'm wanting to bring in are system collections generic, base component systems, and which I won't worry about that namespace, and base infrastructure. So those are going to be the primary interfaces that we need to make sure that we import. And I'll... Yeah, that's fine. Okay, so I'm going to say text writer dot writeLine, and we're going to pass in using system. I'm going to get in the habit of doing a writeLine for every single line. Oh, also make sure you terminate there. And the reason for that, so system collections dot generic, is because I wanted to have a chance to apply its indentation. Now, yes, there is no indentation at this point, but that's not the point. So buzzmmo.base.components.systems and text writer writeLine using buzzmmo.base.infrastructure. And it also will put in the proper line breaks, the /r/n for Windows, without us having to use environment newline or do it manually ourselves. Anyway, so once we're done with our imports, I'm going to say namespace. I'm going to open up a namespace. So now we're on line 11 right here. You see right here? We're on line 11. So we're going to say namespace buzzmmo.base.generated. Then I'm going to say textWriter.writeLine, and I'm going to open up a curly. Then I'm going to say I'm going to add an open block and then close it, and then add a textWriter writeLine end curly. Oh, whoops. I already forgot. TextWriter indent ++, and then TextWriter indent -, and then close. So this is how we're going to handle our indentation. We're basically going to write an open, do an indent ++, and then write a close. You know what? That's going to get really super boring. So what I'm going to do here is I'm going to write a helper method. I'm going to say private void indent and indent block, or indented block, indented text writer action. Actually, you know, it'd be a lot nicer than that. A extension method. I'm gonna go ahead and add a. I wonder. No, I don't think you can. You know, I've never tried to do this before. I wonder if you can do a static class extensions. Public static void. Just give me a sec. I want to see if there I am again. I can't type for some reason today. Indented text writer that action. So can you? No, you can't. Extension methods can only be declared in non-generic, non-nested static classes. Okay, so you can't do it in that. I've never tried. I knew you can't do an extension method in an instance class, but I thought you may be able to do it in a inner static class, but that's okay. Let's just do it in an external static class that's in the same file. And then I'm going to leave the modifier as just static class. In fact, I could go ahead and just say internal for the sake of explicitity, or explicitness, and so that this extension method is only locked down to this one particular assembly. And then the right indented is simply going to say that, or sorry, how about indented block, I think is a better term. It's simply going to be that dot right line, open that dot indent plus plus, action invoke, that dot indent minus minus, that right line, close. So that's going to be our nice little indented text writer extension method, which will clean up our code quite a bit. Because now with that extension method, I can go ahead and replace all this code with simply text writer dot indented. That's not how you spell indented. Indented block, pass in a multi-line lambda, and now we're in an indented block, saving us quite a few keystrokes. So I'm kind of happy with that. Okay, so now that we've done that, what I'm going to do is I'm going to say for each var component in component map dot all components. Now make sure that you're iterating over all components and not components. If you recall the distinction, all components returns an enumerable of all the actual components, whereas components is a public array that is going to be it's going to have 256 values in it, and most of them are going to be null. Whereas all components returns all the non-null mapped components, so that's why we want to use all components here. And then I'm simply going to say text writer dot write line. Class doesn't even need to be public. We can just say internal class underscore underscore placeholder placeholder. Okay, so what's the first placeholder? Well, they're both going to be component type dot. Well, the first one's going to be component type name. Second one's going to be component type dot full name. So why is that? Well, let's go ahead and look at. I wonder if it'd be better if I brought that down here instead. Okay. So you notice how this public class underscore underscore ilogin system server, I want to go ahead and have the full name for this. So it'll be buzzmmo.base.components.systems.ilogin system server. That way we won't have to worry about the namespace of that particular component. So if we add a new component to a new namespace, we won't get a compilation error. However, with this, you notice that I don't want the full name because I just want the name of that. Okay, so we're going to say for each all components, we're going to create an internal class. After an internal class, we're going to say textWriter.indented block. We're going to open up a new indented block. So that brings us right here to these fields. So I'm going to say textWriter write line private read-only mapped component semiline semicolon textWriter write line private read-only iStatic proxy interceptor. Then I'm just going to copy and paste this line and replace the last bit with mapped method array methods. Okay, so we have written all of our awesome fields. Let's go ahead and implement our constructor. So our constructor is going to be textWriter write line, and it's going to be public underscore underscore placeholder, or placeholder, then open parenthesis mapped component iStatic proxy interceptor. And then we're going to say textWriter dot indented block. Again, I told you this would save a lot of typing. And now that we're in here, we can go ahead and write our awesome constructor, which is simply going to be textWriter dot write line, and we're going to pass in component equals component. We're going to pass in interceptor equals interceptor. We're going to pass in methods equals new mapped methods array of blank, and the blank is going to be component dot method count. Okay, so now the tricky part. So now we have to go and actually go about writing our mapped method components, remapping our mapped method components, if you will. So what I'm going to do is I'm going to say for var I equals 0, I smaller than component dot method count I plus plus. That'll give us the index of the method, which will be handy. Then I'm going to go ahead and say text writer right line methods at I equals component dot get method type of, and now we're going to pass in another placeholder. This placeholder is going to be, or sorry, 1. This placeholder is going to be the fully qualified name to the type. So get method type of blah dot get method. So we're going to have 2 get methods in here, which is interesting. And now what we have to do is we have to pass in an array of types that represent the parameters. So what I'm going to do here is I'm going to break this off. I'm going to say get method, and then I'm going to pass in a, well, no, not yet. First, I'm going to add 2 escaped double quotes with a 2 placeholder, and then I'm going to add another comma there. Then I'm going to say new type array and open up array initialization syntax. Okay, so now that I have that line done, let's go ahead and fill in the blanks. The first blank is our index. The second blank is our component.type.fullname. And our third blank is our method name. So it's component.methods. Well, actually, instead of doing it like that, what I'm going to do is at the top of the for each loop, I'm going to say var method equals component.methods at I. So now I can say method.methodinfo.name. Okay, so that's really, really long. So what do we have going on here? Well, first of all, I made a mistake right there. It should be right, not right line, because we don't want to end the line. Also, this should be a double, right here. That needs to be a double open curly in order for it to escape it being a curly in a format string scenario or context. Okay, so what's going on here? Basically, we have our methods array being indexed by our I variable, and we're assigning it to component.getMethod, which is the mapped component that's passed in. Then getMethod, if you recall, expects a method info. So we first get the type of the interface that we're implementing, and then we invoke getMethod on it, passing in the name of the method that we're trying to get the method info of, and then a type array. Now the type array is going to correspond to parameters. This is what's going to allow us to handle overloaded methods. So after doing that, I can now write out a list of all the types, of all the parameters. So what I'm going to do here is I'm simply going to say for var I equals 0, I small, or sorry, I'm first going to say var parameters equals method dot method info dot get parameters. Method info has this get parameters method, which turns an array of parameters. I like aliasing out into a variable. So I'm gonna say var p equals 0, p, or actually, what am I? Well, yeah, I do need an index here, don't I? P is smaller than parameters dot length, p plus plus. Then inside of here, I'm gonna say text writer dot write, and I'm gonna pass in the type of that parameter. So I'm going to pass in type of open placeholder close. And then I'm going to, for the placeholder, I'm going to pass in parameters at p dot parameter type dot full name. Okay, the last thing I'm going to do is we need to insert that comma. The way I like inserting commas is I like doing it at the beginning of the for loop. I like saying if p is greater than 0, then text writer dot write comma, and this will write out our type array. Anyway, if you guys haven't done a lot of string processing like this in the past, this is a great practice. Generating code like this is getting great practice in for dealing with writing out formatted text. But the more you do it, the more you get used to it, and it stops becoming all that scary. You start thinking about, well, yeah, I have to deal with the comma, I have to deal with escaping that curly, and so on and so on. Okay, let's go ahead and write the end of that line. So now we've written all of this. We simply have to close our type array, and we have to close our get method thing. By the way, I do realize that I'm missing the type array in this example. If the type array were here, it would look like new type array type of int, for example, because this method has an int parameter. So it would look like this. So that means at the end, we're going to say, we are going to use write line in this case. We're going to say end curly, which ends are implicitly our array initialization. Then we're going to say two close parentheses and then a semicolon. The first parenthesis that's closing is going to match right here, the get method that we're invoking. And then the last parenthesis that we're closing is the similarly named get method, which does a completely different thing. Awesome naming there. I know it's my fault. Okay, so what we have here is we have our constructor. So now that we have our constructor, we can move on into our methods. Our methods are going to be pretty straightforward. So what I need to do here is right here, no, after this is our constructor block. I'm going to go ahead and add a new line, and I'm going to go ahead and move this out of the way. That's getting really annoying. I'll look at this off screen, because I can't stand looking at that right anymore. Okay, so after we've done that, now we write our methods. So what I'm going to do is I'm going to say for I equals 0, I smaller than component dot method count I plus plus. Now, the reason we're doing this in a for loop and not a for each loop is so that I get the index. And what are you complaining about? Access to for each variable enclosure. No, that doesn't matter. You can ignore that. Error or warning if you have Visual or ReSharper installed. Okay, so I'm going to say var method equals component methods at I. And then the first thing we're going to do is we're going to write the method header. The method header, what is that? Public, return type, method name, parameters. Pretty simple stuff. So what we're going to do here is we're going to say text writer dot write. We're not going to do write line because we're going to have to enter in another loop to put in the parameters. We're going to say public placeholder for the return type, placeholder for the name, open parameter list. First placeholder again is the return type. The return type is method.methodinfo.returntype.fullname. Well, actually, that's not going to be right. The return type is going to be a little bit more complicated than that, actually. So, actually, what I'm going to do is I'm just going to say public. I'm going to say write public, and then I'm going to write the return type manually. So I'm going to say if method.returnType is void, then text writer write void. Else if method return type equals response, then text writer write IRPC response. Else if method return type is response with result, text writer dot write IRPC response, open generic argument list, open a placeholder, and then for that placeholder pass in method dot result type dot full name. And we can also throw in a sanity here. We can say throw new invalid operation exception, return type blank not supported. Oh, what? Stop, go away. Method result type. Okay, so that is our return type. The reason I do it this way, instead of doing the method.methodinfo.fullname, is that'll mangle generics. So I really wanted to. It won't look very pretty if you have a generic return return type. So that's why I'm doing it manually here. But there's only 3 cases we have to worry about, so it's not that big of a deal. Okay, so now I can say textWriter.write, and after we've done our return value, I can enter a space, enter a placeholder for the name, and enter an open parenthesis for the parameter list. Now the name, of course, is going to be method.methodinfo.name. Now for the parameter list, I'm going to say I'm going to say var parameters equals methodinfo get parameters, just like what we did before. I'm going to say for var p equals 0. I told you guys this would be lots of fun. P is smaller than parameters length p++. If p is greater than 0, text writer write comma space. Otherwise, or in addition to that, text writer write parameter type parameter name. So parameters at I dot type dot full name and parameters at I dot name. Those are our parameters. Now we can say textWriter.WriteLine, and we can finish off the whole method by just ending a parenthesis right there. So that is the implementation of the method. Super fun stuff. Now let's go ahead and say textWriter.indentedBlock and open up a block. In this block, we are going to write the implementation of our method. Now, the implementation of our method is pretty straightforward. We have 3 possible results. So what I'm going to do here is I'm going to say if method.resultType is void. Is it result type or return? No, it's return type. If return type is void, then the implementation of the method is textWriter.WriteLine. All it's going to be is underscore interceptor dot intercept void method. And then we're going to have our underscore method reference that'll be indexed to a placeholder. And then after that, we'll have an array of objects that'll open up, and that will be our parameters. But of course, we won't go ahead and we won't write that yet because we haven't written out our parameters yet, so we're just going to open it up. For the placeholder, we are going to pass an I, which is the index of our method. You know, this method's got so big, I really should break it out into multiple methods, but I'm not going to bore you guys anymore. But at least one refactoring I'm going to do. This for loop has gotten so big that the concept of what I is has really been lost. And because what the concept of I is has really been lost, I'm going to rename it. So I'm going to put my keyboard cursor on I and hit Control-RR and say method index. And that's going to change it to method index. That makes it a lot more clear what we're looking at. Now, for this guy, of course, we do need to escape that open curly as well by doing a double open curly. All right, then I'm going to say else if method.returnType is response. Then I'm going to say textWriter.WriteLine return, because if it's a response, that means it returns an IRPC method. Return interceptor.intercept method. What did I call that? Intercept method with response is what I called that. It's a really long method name. Then we're going to pass in method index, which will have a placeholder. And then we're going to pass in new object array and escaped that method index. Okay. Then we're going to say if method.returnType is response with result, then textWriter.WriteLine return interceptor dot whatever I put in here, intercept method with result. Generic parameter. First placeholder will be the generic parameter, or the generic argument, rather. Second placeholder will be the index into main, or method. And then the parameter is going to be a new object array that's escaped. So the first thing is, first index, or first placeholder is going to be method.returnType, result type dot full name, and then method index as our final parameter. Now I have made a small mistake, and the mistake is I was using textWriter.WriteLine instead of textWriter.Write. Notice how we have this new object array opening up. I want to go ahead and make sure that that is on this. All of this is on the same line. So to do that, I'm going to replace this write line with just simply write, and then we'll write out our parameters. Okay, so now we can go ahead and we can write out our parameters. Super exciting stuff. Basically, all we're going to be doing is writing a list of names. Each name corresponds to a parameter. So I'm simply going to write for var p equals 0. P is smaller than parameters.length p++. Then I'm going to simply do if p is greater than 0, TextWriter write, comma. Otherwise, or in addition to, TextWriter.write parameters at p dot name. And that's almost it. The last thing I'm going to do is at the end of the method, I'm going to say TextWriter.writeLine, and I'm going to end the parameter list, the object list, and then I'm going to end the parenthesis, and then I'm going to terminate the line with a semicolon. Okay, so that is the first half, or that's way more than half of what we're going to be needing to do, actually, because all that's left now is to create the generator. However, I do want to go ahead and check this to make sure it's all working. So what I will do, I'll go ahead and take all that code that I had written in there for reference purposes, and I'm just pasting it into a Sublime window so that I don't lose it. What I'm going to do now is I'm going to hit F6. By hitting F6, we're going to see the result of our generated code. So hit F6, wait a year or two, and hit yes to all. Okay, looks like we have an error. So coming over here, let's look at what we got wrong. Things actually look pretty close to how they should. There's a small problem though. It looks like we haven't quite done the proper placeholder for the constructor name. We also got an error. Let's go ahead and I'm going to exit full screen so I can look at my output. And I'm going to see exactly what error we got when we were compiling. Or when we got an exception that was thrown somewhere. And I don't know where. Oh, an exception has been thrown as a target in the invocation. Well, that's helpful. Okay, let's fix the first part here. The first part is this. This should be that. Second part is I misspelled proxy interceptor. And then the third problem is I missed a new on instantiating that array. So, let's fix all that. First, the constructor. So the constructor, I forgot to, up here on line 50, I forgot to pass in component.type.name. Second problem is I forgot the new on the array. So let's go ahead and do that. Here on line 55, make sure that you added the new parameter, or the new operator. And then the other problem is I misspelled static. I did static X, or static, can't even pronounce that. Misspelling. Hurts my brain. All right, let's hit F6. And come back here to component interfaces. All right, so now we have a problem with our login system server. Looks like we're having an exception that is thrown. Well, first of all, we have an error right here. In our bodies of our methods, I unfortunately forgot the S. Second part is we are having an exception occur right here right about before we were about to print our arguments, or our parameters. So let's come back down here and let's look at our methods. So right here, we have, where was that problem? Right here on line 104, when we generate the body of our method, I'm using methods, or method instead of methods. So let's go ahead and change that all to methods. All right. And let's go back here and let's figure out what has gone wrong here. So our IRPC response, it shouldn't be an IRPC response, it should be an IRPC method. Let's fix that first. Let's jump back into generate commands and change IRPC response all the way back up here at the top, this return type, to IRPC method. And Then let's look at the parameter list and what is going wrong with that. So we open up that, and then we get an error right here, apparently. Or an error right here, potentially. Oh, I'm accessing parameters at method index, where it should be parameters at p. Well, that was dumb of me. All right, let's hit F6. Let's jump back into component interfaces and check that out. Everything is working except for some missing semicolons. So now you see or basically everything how it should be. All of the different generated classes are all being generated properly. So the last problem is up here. We're missing 2 semicolons on the using statements. So let's go ahead and jump back into generate commands. And, you know, I don't even really need this BuzzMMO base component system at all. So I'm just going to clear that out. But we do, of course, need BuzzMMO base infrastructure. So I'll add that semicolon in there. And then I'll go ahead and hit F6. And we got a build succeeded, which means our generated code did compile. All right, let's come back in here and let's just wrap up by creating our factory. So remember, our factory is just going to be, it's going to be like this. It's basically just going to be a public static class that has a dictionary of factory methods. The only dynamic bit is going to be this code right here, where we add all of our systems to. So let's go ahead and find out where our methods or all of our components end. That's going to be right here. By the way, at the end of this video, I'm going to refactor this method out because this method is getting way too big. Okay, so let's go ahead and write out our factory. So our factory is simply going to be textWriter.writeLine public static class component proxy factory. Then I'm going to say textWriter dot indented block, and then I'm going to say textWriter WriteLine. We're going to need a private static read-only dictionary of type and of func of mapped component iStatic proxy interceptor, and returns an object. We're going to close 2 generic parameter lists, and we're going to call this underscore factories. Then I'm going to say textWriter WriteLine public, or sorry, just static component proxy factory, because static constructors can't have accessibility modifiers on them. And then we'll say indented block, open up the constructor. For the constructor, the first thing we need to do is instantiate our factories. So I'm simply going to do factories equals new dictionary of type and func mapped component iStatic proxy interceptor object, and go ahead and terminate the line. Also, be sure to terminate the line where you have your field here. Then I'm going to say for var I equals 0, I smaller than, let's see. Actually, no, I don't need to do that. I can simply say for each var component in component map dot all components, and for every component, I can simply write line factories dot add type of, and then put in a underscore placeholder, comma, and then we need to open up a lambda that's going to have comp inner, short for component, and or sorry, this isn't going to have 2 underscores. This is going to have simply the type of, this type of is going to be the interface itself. It's not going to be the generated type. So then the factory method will have a new instantiation. This one will have 2 underscores. And then we'll pass in that placeholder. We'll pass in comp and inner. And then we'll close out the method invocation and terminate the line. Now, just like I said, the first placeholder is going to be component.type.fullname, and the second one is going to be component.type .name. And that's really all the dynamic code we need for our component proxy factory. So now I can go ahead and add another member. So I'm going to say textWriter.writeLine, and I'm going to say public static object create. And it's going to take in a mapped component, and an iStatic proxy interceptor. And then I'm going to say textWriter dot indented block, open that up, and we're simply going to have one line of code here, which is going to be return factories indexed by component.type. Then, now this is important, don't skip the next bit of punctuation. It's vital that you do this because the code will still compile if you skip the next bit of punctuation, but it'll be incorrect. Open up two parentheses and pass in component and interceptor. And make sure to terminate the line. Now I'm going to hit F6. And our build succeeded. So now let's jump back into component interface. We didn't get a rebuild here, unfortunately. So let's try that again. Okay, we're not going to get a rebuild on that unless I go and change something in the base project. So I'm going to go in the base project, I'm going to go in my component systems folder, my character select system, and I'm going to say void bleh. And then I'm going to hit F6. And now it regenerated. So now I'm going to go in component interfaces. And everything looks pretty good. And we can check out right here that our component proxy factory now has all of the proper factories added into it for our different systems. Alrighty, so that is our code generator. Now the last thing we're going to do here is I'm going to tidy things up a little bit. First of all, I'm going to take this for each loop on all components. And I'm going to shift click down and take all of this code. And I'm going to hit Control-Shift-R. And I'm going to say extract method. Hit enter. And I'm going to say generate proxy classes. And hit next. And now all my proxy classes generation is in its own method. Now I'm going to take this code right here that generates the proxy factory, hit Control-Shift-R, hit extract method, and I'm going to say generate proxy factory. Then I'm going to move proxy factory underneath generate proxy classes by holding Control-Shift-Alt and hitting the down arrow key. Then for the constructor, I'm going to do the same thing. I'm going to go ahead and grab all of the constructor. I'm going to say extract method. And I'm going to say generate class constructor. Hit enter. Then I'm going to go ahead and take the method. Inside of the loop, I'm going to take the method and I'm going to grab the entire contents of it, hit Control-Shift-R, hit extract method, and say generate method. And I guess I can leave it at that. I could maybe break generate method into two more methods, but I think for now it's fine. So it's the same amount of code, but I've reduced the indentation, and now the process is much easier to see for someone who hasn't read this code. We simply open our namespace, we generate our proxy classes. Every proxy class that we generate a constructor, then we loop through their methods. In fact, I can go ahead and inline this right here, inline that variable by hitting Control-Shift-R and inline. And then our generate method class generates all our methods, our generate class constructor, which I want the generate method to be underneath the generated class constructor method. And then we have our generate proxy factory method. And that's it. All right, so yeah, fun stuff. I guess that's about it. We'll see you in the next video.